Okay, so today we want to talk about trigonometry, everybody's favorite topic. So there's a lot of stuff we could talk about in Appendix D, I think. But I will post maybe what's called a trigonometry cheat sheet. And you should follow along that. That'll be on the class website. I'll try to remember to put it on Canvas as well. I'll put it under today's right before this video. So the idea here is that we want to basically review a semester's worth of trig in about 15 minutes. So I think the way to do that is to start off with right triangle trig. That's the way normally we start it. So if given a right triangle here, let's say this is the angle theta, and this would be the side adjacent, this would be the side opposite, and this would be the hypotenuse. Okay, and so the trigonometric functions represent ratios of the three sides of the triangle. So the three that we are typically working with are the sine, cosine, and tangent. So let's write those down. The sine is the opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is sine over cosine, or you could write it as opposite over adjacent. Good. With each of these you have the reciprocal. So the reciprocal of the sine is the cosecant. So that would be hypotenuse over opposite. The reciprocal of cosine is secant. So that would be hypotenuse over adjacent. Excuse me. And the reciprocal of tangent is cotangent. So that would be adjacent over opposite. Good. Now, from here, we can talk about if I'm given a triangle and I know one of the angles, right, then I should be able to get the other angle. So I'm going to pause here for a sec. Okay, so sorry about popping that up on you, but I just wanted to see, so suppose the sine of theta is 3 over 5, where theta is between 0 and pi over 2, so that our picture is accurate. Then can we figure out the other 5 trig functions from that? Well, from this, we can say that the side opposite theta has length 3. The hypotenuse has length 5, or we could multiply top and bottom by any number as long as they're the same number, because this is just the ratio, right? This 3 to 5. Okay, and so if opposite is 3, hypotenuse is 5, then we can find the length of the third side using the Pythagorean Theorem. So therefore 3 squared plus opposite squared, adjacent squared, sorry, that's the one we're looking for, is equal to 5 squared. So let's see, adjacent squared then is going to be 25 minus 9, which is 16. So the side adjacent has length 4. And so this is the infamous 3, 4, 5 triangle. And so now you can compute the other 5 ratios, right? What would the cosine be? Cosine theta would be 4/5. Tangent theta is opposite over adjacent, so 3/4. And then what would our other measures be? Cosecant would be 5/3. Secant would be 5/4. And cotangent would be 4/3. Good. And so you can try some more of those in the homework. From this, let's talk a little bit about angles and circles. And then we'll see where this fits. So we know that a circle, if you draw it on the x-axis here, so xy, the equation of a circle of radius 1 is x squared plus y squared equals 1, right? That's the unit circle. So let me put a 1 there. 1 there. Okay, so we know that a circle has 360 degrees, and a circle also has 2 pi radians. Okay, so how do we do conversions from one thing to another? Well, if you have x degrees, then how many radians do you have? Well, you can say that x is to 360 as your radians is to 2 pi. Right, so then the radian measure would be, whatever the radian measure is, it's going to be x over 360 times 2 pi. Or you could say that you're taking your x times pi over 180. That's the way some people will remember it. Okay. Similarly, you could find a formula in the other direction, right? So if you have t radians and you want to convert that to degrees, then you can say the number of degrees to 360 is equal to t radians to 2 pi, right? So then the number of degrees that you have is going to be t times 360 over 2 pi, which is t times 180 over pi, which is the way some people will remember it. Good. Now I should say that in calculus we always use radian measure, and we'll see why later on. I'll bring this up again later, but you always want to use radian measures. Okay, so now let's take a look at this circle again. I'm going to draw a new picture of it now that we know how to compute angles on a circle. And if this is x and this is y, I create a triangle. Okay, so this is this point right here you could think of as xy, right? xy 1. And so if this is our angle theta here, then we can think of sine of theta is y over 1, cosine of theta is x over 1. So we think of x and y, the ordered pair, you could actually write as cosine theta, sine theta. Okay, and so from the formula of a circle, we also get that cosine squared theta plus sine squared theta equals 1, and this is known as the Pythagorean identity. Okay, so this is true for any theta. That's what we mean by identity, right? It's true for every theta. Good. All right. Now, by the way, because you're given cosine and sine, right, we could also figure out the tangent. Tangent of theta is sine over cosine, so that's going to be y over x. And then we could also get cosecant, which would be 1 over y. Whoops. And secant, which would be 1 over x in this case. Okay, good. All right, now before we get too much further here, there are two important triangles that we want to remember. Two key triangles. One is going to be the 45, 45, 90 triangle. And the ratios of the sides here, because these are equal angles, this is going to be 1 to 1 to the square root of 2. So those are the ratios of the sides. And so because in calculus, right, we want to always use radian measure, think of this as, oops, yeah, pi fourths, yeah, 1 square root of 2. Good. And so from this triangle, we can compute all six trig functions, trig ratios. Good. And the other key triangle is the 30, 60, 90 triangle. And the idea is that the ratios of the sides are 1, 2, square root of 3. And so which side goes which angle or which measure? Well, 1 goes opposite the smallest angle. And then is 2 or square root of 3 bigger? 2 is bigger, so 2 goes on the hypotenuse, square root of 3 goes there. So if you can remember this one, by the way, this is going to be, oops, I shouldn't have wrote it that way. Sorry about that. Oh, this is not to scale. Pi sixths, pi thirds, 90. Okay, I just reversed it for you. I hope you didn't get confused. Okay. So again, we can compute all 6 trig functions. Okay, so these two triangles you really want to remember. These two you want to remember. Because from those two we're going to be able to get lots of different angles on the unit circle, which is what we'll explore in the next video.